This is the video for 2.5, and we are going to be talking about literal equations. What exactly is a literal equation? It's an equation that involves two or more variables. So for example, 10x plus 5y equals 80 is a literal equation. And a formula is a type of literal equation that states a relationship among quantities. So for example, if I say the area of a triangle equals 1/2 the base times the height, that formula tells us the relationship between the area and the base and the height. So in the first example, rewriting literal equations, it says solve the following equation for y. So what we're going to do is we're going to circle out the term that has the variable we're trying to solve for, and we're going to deal with that term last. And we want to get everything away from the y so we can isolate the y, which means bring it to one side of the equation by itself with a coefficient of 1. And so I'm going to start with this positive 10x. So I want to undo that operation through subtraction. So that means I want to subtract 10x from both sides. And so then I'm left with 5y equals 80 minus 10x. And this is as combined as those two terms can be. So another way to look at this, when I say we can subtract 10x from both sides, you can also look at it as I'm adding a negative 10x to both sides. So now I don't want to know what 5y is, I want to know what 1y is. So I'm going to divide both sides by 5 because that will give me 1y equals 80 minus 10x divided by 5. And because these terms can reduce, I want to break them up so I can reduce them. So I have 80 over 5 minus 10x over 5. And then I reduce each term. And this is my answer. I think 80 divided by 5 is 16. Let me just double check. And yes, it is. But I will accept that as an answer right now, but just to let you know that's not appropriate form. It's appropriate to put the term with the variable in it first and then your constant last. And notice what I did here. I just switched the order of the terms, keeping the sign. So I have a positive 16 and a negative 2x, and here I have the same thing, a positive 16 and a negative 2x. So you can switch the order as long as you keep the same sign. And now what do? It says, what is y when x is 3? I just plug in 3 for x and I solve. And so then my answer is 10. So go ahead and do this on your own. Solve for m. Okay, so I want to solve for m, so I'm going to circle out the term that has the variable I'm trying to solve for. I want to deal with that last. So I want to add 5n to both sides. And when I do that, I get 2m equals 5n plus 4. Right away at the very beginning, I'm going to go ahead and put the term with the variable in it first because that's appropriate form. But if you don't remember to do that right now, it's fine. And I'm going to divide both sides by 2. And that gives me 1m equals 5n plus 4 over 2. And because this can reduce, I want to break it up. And so then my answer is going to be 5n over 2 plus 2. Or you could say 5 over 2 times n. Either way, it's the same thing. And so what is m when n equals negative 2? These cancel out, so I'm left with negative 1 up there. So 5 times negative 1 is negative 5 plus 2, which is negative 3. And that's my value of m. Okay, so let's go to example number 2. Rewriting literal equations with only variables. Let me rewrite this. a little bigger so you can see what I'm doing. So I want you to think backwards. You know about the distributive property, and so now I want you to go backwards. And so instead of instead of distributing the x into the terms, we are going to be factoring the x out. And so once I factor out or pull out or divide out or undistribute the x, however you want to word it, once I undistribute or factor out the x from that term, I have an a. And then when I factor out the x from that term, I have a negative b. Undistribute is actually a term I made up. It's not a real word, but I think, well, we distribute going this way, and so then we undistribute going that way. It's actually called factoring it out, but we haven't learned that term yet. But let me just prove to you why this works. So look at what happens when I distribute the x back in through multiplication. Do you see how I end up with what I began with? And so that's my proof as to why these two equations are the same thing. So let me go back over here at the beginning. So I have ax minus bx equals c, and so I want to pull out the x from each term, and I can't just make it go away, I have to include it there. And so now I want to solve for x. And my whole purpose of doing this is I can't solve for x if x is all over the place. I have to get it in one spot. And so this x is connected to this a minus b, which is grouped together through multiplication. So that means I'm going to undo that operation through division, and I'm going to divide both sides by a minus b. And once I do that, they cancel each other out over here. So in other words, that becomes 1. Anything over itself is 1. And so that becomes 1x, or you can just say x, equals c over a minus b. And that's my answer. So go ahead and hit pause and work out this on your own. And like always, if you get it wrong, stop the video and redo it. You can rewind the video and rewatch it. Always work things out by yourself if you get them wrong. Or even this one. Pause the video and go ahead and work it out yourself. Start over and try it again from the beginning and see if you can get it. Okay, so it says solve the following equation for x. So I want to get everything away from x. So I'm going to circle out the term that has the variable. I want to deal with that last. And I have a positive r. And so what I'm going to do is I'm actually going to subtract r from both sides. Or you can think of it this way. I'm going to add a negative r to both sides. I'm actually going to work it out horizontally because I'm dealing with all variables, and you can see it better. Let me make sure you fully understand what I did. Let me rewrite this bigger. I had negative t equals r plus px. And I have a positive r here. So what I'm going to do is I'm going to add a negative r to both sides. Because when I do that, these cancel out. And the reason I started there is I want to deal with the term that has the variable in it last. So now I have negative r minus t equals px. I want to solve for x. P is connected to the x through multiplication, so I want to undo that operation through division, and so then I'm left with x equals negative r minus t over p. Oops. And so there's your answer. And stop the video and rework it if you need to. Rewind it, watch it again. That's why it's so nice having these videos. You can watch them as many times as you need to until you get it. Okay, now we're going to rewrite a geometric formula, solve for r. Remember, a formula tells us a relationship among quantities. So let's think of it this way. I want to solve for r, so I need to get the 2 pi away from r. The 2 in the pi is connected to the r through multiplication, so I want to undo that operation through division. So anything over itself is 1, but what I do to one side, I need to do to the other. So I'm going to say that the radius equals the circumference over 2 pi. So let's look at that relationship. The original problem says that the circumference equals 2 times pi times r. So then we can also say that the radius, because, okay, let me re-say that. The circumference equals 2 times pi times the radius. So then we know the radius equals the circumference divided by 2 pi. This is why a formula tells us a relationship between quantities. And so then it says, okay, well now that you did that, what is the radius of a circle with a circumference of 64 feet? Pi is 3.14. And so then my answer is going to be 10.2 feet. Okay, so pause the video and work out the on your owns. Okay, it says solve for h. So I have a fraction here, so I want to get rid of the fraction, so that means I'm going to multiply both sides by the denominator. Or you can think of it this way. I have 1/2, and so what I want to do is I want to multiply both sides by the reciprocal. So I'm going to multiply both sides by 2/1. And once I did that, these cancel out. And so then I'm left with 2a equals the base times the height. And then it says I want to solve for h. So that means I'm going to divide both sides by the base. And then I'm left with the height equals 2a divided by b. Again, I had 1/2 the base times the height. So I need to think of it one of two ways. I either need to think, well, I have a denominator, so I'm going to multiply both sides by the denominator, or you can think of it like this. 1/2 the base times the height. What I want to do is I want to multiply both sides by the reciprocal, which is 2/1. And so then what is the height of a triangle that has an area of 1/2 inches squared and a base with a length of 8 inches? And the answer is 6 inches. Okay, so go ahead and hit stop and work on your homework. And this lesson is extremely important for chemistry. It's also very important for geometry. And it is difficult manipulating these formulas that only contain variables, but you will get used to it, I promise, and you will get better at it.